Hello everyone. Today we are going to learn 2.2 separable equations. So let's find out what does that mean. So we have definition separable equation. So a first order. So we know what is a first order, right? So differential equation, first order, first derivative, right? First order differential equation is separable if, okay, look, we have h of y times y prime. That is a first order, right? Equal to, normally we had f of x, but they have g of x, but it's the same, right? So other side we have a function. It can be constant or the function, right? Look, we call this as a product. Yeah. So we called this is not linear. So how do you know linear first order? We did that a couple times already, right? So linear first order, the form is y prime plus polynomial, then times y equal to other side is f of x. Yeah. So we call this is not linear. And then why? Because product of y and y prime. So this is function in terms of y. Can you see that? This is the function in terms of x. Yeah. So I said think y is one side and x is the other side, right? So last time we did that homogeneous equation, right? With first linear order, linear first order linear, right? Yeah. Okay, so let us do this one. Solve y prime. Okay, so we want to make y is one side and x is other side. All right, so let's do that. What's the first job in that case? We need to move to here, right? So that divide by 1 plus y squared, both sides. Okay, so we have y prime over 1 plus y squared equal to x. Yeah. Okay, now what we do, y prime. So, sounds weird. Y prime, which is, we can use dy dx. Dy over dx, yeah? So dy over dx as y prime over 1 plus y squared equal to x. Now we multiply by dx, yeah? Dx, dx. So we will have dy over 1 plus y squared equal to x dx, yeah? Now we take the antiderivative, which is integral, right? So let me make one more page. So we will have integral both sides. So we have dy over 1 plus y squared, which is x times dx, yeah? Okay. Can you please think about that? What is integral of 1 over 1 plus x squared? We studied that, right? I mean, it's the same. Think 1 over 1 plus x squared. Very good. It's arctangent. So arctangent, we denote this way, right? Arctangent, inverse of a tangent, right? Okay. So let me write down here. So that will be left side will be arctangent. In that case, it's y variable, right? So y equal to, what about the other side? Antiderivative. So we add one more power, right? And then divide by new power. And then other side, we make a plus C, right? Because we want to solve for y, right? So other side, we will have a plus C, not the left side. Okay, then note. So in the inverse function, we have AB makes in order pair B8, right? That's why domain of this function will be remain of the inverse function, right? Okay, so that means inverse of arctangent A equal to B. That will be, we switch over, so it will be arctangent B equal to A. Yeah. Okay, let me write down inverse function. Okay, so in that case, we can switch over that with this. So this will be inside here, then this will be outside, right? So that will be y equal to tangent, tangent, it's been a while, tangent x squared over 2 plus c. That is general solution. You guys okay? Very good. Okay, so let's take a look other questions. So we have solve equation, and this time they give us initial value. Yeah. So we had the experience, couple two sections, right? Okay, let's do this. A y prime equal to minus x over y. Okay, we want to make one side with y variable, which is product of y times y prime, right? Okay. This is just a simple, right? That's it. Okay, so we will have y, and let's make a dy over dx, yeah? Equal to negative x, then dx, dx. There will be y dy equal to negative x dx, yeah? Now, take the integral, both sides. So y dy equal to minus x dx. Okay, so left term, left side, we get y squared over 2. Yeah. Right side, we have a negative sign, x squared over 2. Antiderivative, right? And plus C. Okay, now we want to solve for y, right? General solution. Then we make a times 2. So that will be y squared equal to negative x squared plus 2c. All right. Now we want to find y, yeah? So we want to solve for y. Um, hold on one second. Let's say this is A. This is A square, sorry, A square. Okay, square equal to 2C, like we had earlier. E to the B whatever equal to C, like that. Previous section, right? Yeah, same as here. So let's make a little bit convenient the letter variable here. Okay, then if we move to this negative x squared to the other side, there will be positive x squared plus y squared equal to a squared, right? Okay, so we've seen this one before. This is equation of circle, right? So we did that this one in the beginning, right? Okay, so there will be equation of circle. Okay, now we start for y. Okay, so start for y again, then move back, then that's negative x squared, right? Then a squared minus x squared, and we have y squared. So y equal to, take the square root, plus minus, right? A squared minus x squared, right? Okay, so let's write down. So y equal to square root um, plus minus a squared minus x squared. Yeah. All right. Look, we have square root, right? So we don't want inside the square root complex number. So we want inside the square root real number, right? Then what's the domain of that? Inside the square root must be greater than or equal to 0, right? So 1 a squared minus x squared greater than or equal to 0, right? Then a squared less than, sorry, greater than or equal to positive x squared, right? Then a, take the square root of both sides, so a must be greater than or equal to x. Yeah. And this is a squared. One is positive, other one is negative, right? If we have a negative, put the negative, then the inequality, excuse me, the negative, negative a, and then we have a negative sign. So change the inequality symbol, right? Yeah, from the algebra course. Okay, or negative a less than or equal to x. Yeah. Okay. Then this x must be also between negative a and positive a. Okay. That is general solution. Yeah. Okay. Let me write down. So general solution. Y equal to plus minus square root a squared minus x squared, where X is between negative A and positive A, right? Okay. So A was 2C, right? So, or we can say the plus minus 2C squared minus X squared equal to plus minus 4C squared minus uh, X squared. In that case, where X is between negative A, which is negative 2C, and positive 2C, right? All right. Now, second part, it's given initial value problem, right? So we need to find, copy, such as C. All right, so y of 1 equal to 1. So we have, this is x, this is a y, right? Okay, so that will be, let's using general solution, right? But we can use this one too, right? What do you call? Oh, yeah, we can use this one too, right? Because same. So we have x squared plus y squared equal to a squared. Then x equal to 1, y equal to 1. So 1 squared plus 1 squared equal to a squared. Then a equal to plus minus square root of 1 plus 1, which is 2, right? So there will be, we can use y equal to a. We have a squared minus x squared plus minus a squared plus x, I'm sorry, minus, right? Minus x squared, which is uh, plus minus, let me write down first. Plus minus 2 squared minus x squared. There will be square root 2 minus x squared, right? And then we knew that x is between negative a and positive a, right? So that will be where x is between negative 2, positive 2, right? Okay, let's take a look. Uh, we knew that this equation is equation of a circle, right? All right, then we have x equal to 1, y equal to 1, right? So this will be upper semicircle, right? Okay, so this one telling us upper. Okay, so we want only positive means positive. So we take only positive, yeah? upper semicircle. Clear? Okay, now let's take a look. This graph from your textbook. All right, so any question? Oh no, you can ask. Ah. All right, let's take a look. Okay, so we have implicit solutions of separable equation. Okay, so explicit solution, explicit solution like a regular, common equation. Y equal to x squared plus c. That's the explicit solution. Implicit solution. So like what we did in the calculus 1, implicit differentiation, right? Cannot solve for y, right? So there is not simple like this, right? Yeah. So implicit solution, more complicated, right? Yeah. All right. So let's do next questions. Okay, so we have this equation, this example, implicit solution y prime equal to that. So let us do this. Two x plus 1 over y, 5 y to the fourth power plus 1. Yeah. Okay. So dy over dx equal to 2x plus 1. Then we can multiply that, right? Both sides. So that will be 5y to the fourth power plus 1. Okay, now times dx, both sides. So we have 5y to the fourth power, dy equal to 2x plus 1 dx, yeah? Okay, so we take the integral, antiderivative, sides. So 5y to the fourth power plus 1 and 2x plus 1. Okay, so left side, what do you get? So we do integrate term by term, right? So we have 5y to the fifth power over 5 plus y equal to, and 2x squared over 2 plus x plus c, right? So that will be y to the fifth power plus y equal to x squared plus x plus c. That is general solution, right? So let me denote like that. Yeah. Second part, y over 2 equal to 1. So x, then y. So that will be y to the fifth power. So 1 plus 1, right? So 1 plus 1 equal to 2 squared plus 2 plus c, right? And solve for c. So what's the c? 4 plus 6. 6 minus 2, which is 6. So negative 4, right? Okay, so that is a particular solution. So we have y to the fifth power plus y equal to x squared plus x minus 4, right? So that is a particular solution. Okay, so this graph from your textbook, initial value when x equal to 2, y equal to 1, right? So when x equal to 2, then y equal to 1. Oh, y equal to 1. So that will be 2 and 1, right? 2. So that would be 2 and 1. The curve direction field, right? Like this. Okay. Let us do next one. Next questions. All right. So before we do that, we have one question. All right. So we had a first order differential equation of separable, right? So we have y prime equal to the function in terms of x, right? Then this one, we introduce us different format. Yeah. So look, we have a function and then p of y, which is polynomial in terms of y. Yeah. And also if we use other side is g of x, then we have y prime over the polynomial in terms of y, right? So divide by p of y, both sides, then we get this one, right? So either this one or this one. Can you see that? Yeah. This is the function in terms of y, and y prime equal to the function in terms of x, and y prime differential equation equal to the function in terms of x, and then polynomial in terms of y. Yeah. Okay. All right. So let's do these questions. All right. So we have questions here. Uh, we need to solve for the solution. So let's take a look. So y prime equal to 2x y squared. So divide by y squared, both sides. All right. So we had enough experience. Y prime, we rewrite dy over dx, and then we times dx both sides, right? So let us do everything one step. Make sense? Okay. So we will get uh, 1 over y squared dy left side, right? And then right side we have 2x dx. Yeah. Okay. Now also antiderivative of this one, right? So you think y to the negative 2, add 1, divide by new power, right? So there will be negative y to the negative 1, right? So I don't have to write down, right? You know, right? Because we have experience. 1 over y, right? Ooh, ooh. Then the right side, you want me to write down? Okay, so y to the negative 2 dy equal to y negative 2 plus 1, negative 2 plus 1 equal to negative 1 y plus c. Yeah. Yeah, I have a hard habit plus c all the time. Okay, so right side we will get x squared over 2 plus c. So that will be, oh, we need to solve for y, right? Okay. So 2 out. We can simplify. And make it shorter, right? So basically this will be x squared plus c, right? So we have 1 over negative y. Let's give it to the negative 1 here. We can give it to the top or we can give it to the numerator or denominator, either way, right? But not both, right? Okay, so give it to the negative 1 numerator, and then this will be that, right? So we multiply this way, right? So we have y times that equal to negative 1, right? Okay, and then we need to solve for y. Then divide by x squared plus c, right? Both sides. So this will be, eventually we get y equal to negative 1 over x squared plus c. Yeah, that's how we get it, right? Yeah. All right. Now, that is general solution. Okay, by using b initial value, let us do this. So we have y over 0 equal to y naught. Okay, I kept writing this is x, this is y, right? Same here too. Y naught, y, right? Think about y naught as a number. Yeah, 2 or 3, right? Okay, so x equal to 0, y equal to y naught. Then same concept, same process. So we have a general solution here. Let me copy. Then we say that y naught equal to y, so that will be y naught here, right? Equal to, normally we put the number there, right? So 2 or 3, any number was given, right? But y is y naught in the case, and negative 1 over x squared, x equal to 0, so 0 plus c, right? And we need to solve for c, right? Okay, now, once again, we multiply this way, right? So that will be, we need to solve for c, so c will be c, well, negative 1 over y naught, right? Can you see that? If we have y in the denominator, we want to solve for y, then y equal to, and this will be denominator, right? There's quick way we can think, algebraic way, right? And this one, c is in the bottom, so c equal to, then this will be in the denominator. Yeah, keep the same negative there. Make sense? Okay, now c equal to that, normally we input the c, then that is particular solution, right? All right. So y equal to negative 1 over x squared plus c. C is negative 1 over y. I never read, huh? Y sub 0, y not, right? So read y not or y sub, because subscription subs y sub 0. Yeah. Okay. So let's make a common denominator. So we make a nice form. Okay, so we make a common denominator. So no space. So that would be y naught, right? So we multiply y naught. So that would be y equal to minus 1 over x square y naught minus 1 over y naught. Yeah. Okay. Then we have a fraction divided by another fraction. We make times the first fraction reciprocal of a second fraction. Then this will be negative y naught over x squared y minus 1. Yeah. Minus y naught over x squared. So give it to the negative sign in middle. All right. This is particular solution, right? But then still y naught is a little bit abstract, right? Okay. Let's talk about this one first. We have fraction. So we don't want the denominator equal to 0, right? So cannot have. Don't want, right? Can have x squared y naught minus 1 equal to 0. Is equal to 0 because can't have, right? Yeah. Or we can say that we must have x squared y naught minus 1 is not equal to 0, right? Otherwise, yeah? Yeah, we can say either way, yeah? All right, so let's take a look then. What's the y naught, right? So we have initial value when x equal to 0, then any value for the y naught, right? So let's find out what's the y naught will be. When x equal to 0 here, this is x equal to 0. Can you see that? All right, so the graph, ooh, here, let me see. I don't think this is negative 1.5. It is no, no. Yeah, hold on. Yeah, looks like this is a negative 1.75, right? And then y not equal to negative 1.75. Then what's the next one? This is a negative 1.5. Little bit over or yeah, negative 1.25, 5. Oh no, this is 5. So this is negative 1.25. Uh, let me see. Okay, so I made approximately uh, when x equal to 0, the y value is negative 1.75, negative 1.4, and negative 1.2. So you check it out. Check it out. Yeah, like that. Okay. All right. So let's move on. This will be last question for this section. Okay, so find the solution of y prime equal to 6x squared over 3x squared minus 3. Okay, so let's find the general solution first. And then we have one more extra question. Find the domain. Like earlier, this is basically domain, right? Yeah. We don't want the denominator equal to 0. Yeah. Okay. Uh, let us do this. Y prime equal to 6x squared over 3y squared minus 3, right? Okay, nice questions, right? So we can do just one step everything, right? All right, so antiderivative integrate 3y squared minus 3 dy equal to integral of 6x squared dx. Yeah. Okay, now antiderivative of 3y squared, which is y to the third power over 3, right? So there will be 3 over, yeah, we simplify, right? So y to the third power negative 3y equal to 6. Let me write down, since I have to simplify here. X to the third power over 3 plus c. Okay, so there will be y to the third power negative 3y equal to 2x to the third power plus c. So this is general solution. Moreover, we say the implicit solution, right? So implicit solution. Okay, now we need to find such a C particular solution, right? So second part, the initial value y over 2 equal to 0. So this is x, this is y, right? So we have y to the third power negative 3y equal to 2x to the third power plus c. So that will be x equal to 2, y equal to 0. So 0 minus 0 equal to 2 times 2 to the third power plus c. And solve for c. Okay, so what do you get? 16? Negative 16? Good. Okay, so we have particular solution, which is y to the third power negative 3y equal to 2x to the third power minus 16. Particular solution. Okay, now we want to find the domain. Yeah, find the domain C. Okay, so we had differential equation y prime, the original problem, right? Then it's a fraction. So we don't want the denominator equal to 0, right? So cannot have denominator equal to 0. So okay. 3y minus 3 equal to 0. Now we want to solve for y. So we don't want that, right? So solve for y. Okay, so that would be y squared equal to 1. Yeah. Okay. Then, what is y? Y equal to plus minus 1. Yeah. Okay. Now, we have particular solution, right? Y to the third power negative 3y equal to 2x to the third power negative 16. When we don't want that, right? We don't want when y equal to positive 1, negative 1, right? So when positive 1, negative 1, what's the such x? We don't want that, right? Okay, so when y equal to negative 1, so we have negative 1 to the third power minus 3, negative 1 equal to 2. We need to solve for x in that case. Solve for x. Yeah. Okay. So left side we have 2 equal to 2x to the third power negative 16. And solve for x. So it's a positive 18, 2x to the third power, right? Then divide by 2 both sides. We have 9 equal to x to the third power, right? Okay, now what is x? So cube root both sides. So x will be 2.08. Okay, that case when y equal to negative 1, then how about when y equal to positive 1? So we have 1 to the third power negative 3 and positive 1 equal to 2x to the third power negative 16. So 1 minus negative 3, which is negative 2, equal to 2x to the third power negative 16. And then move to the negative 16, positive 16. So it's a positive 14 there, right? And then 2x to the third power divided by 2, both sides. So we have 7x to the third power, right? Okay, so what is the x will be? So cube root both sides. So x will be 1.91. So we don't want x is like that, right? Because we don't want the denominator equal to 0, right? Okay, so how do we do? So we make it this way. So x is between, which one is the smallest one? 1.91 and 2.08. We did not make an equal sign, right? Because we don't want that. Yeah. All right. That is the domain. All right. Thank you for watching. I will see you in the next video. Bye.